Thank you. Before I start, I've been asked to make an announcement. The idea has been suggested that we write a book called Hyperloop, and that the book will be published under the auspices of the HARP organization. I myself have published books for many years, technical books. And this is still a very initial idea, but the idea would be the book, I think, would be addressed toward the general public. It would not be a technical book. It would have, say, think of a number, 10 chapters. Each chapter will be written by a specialist in that particular area, areas such as security, technology, real estate, different things. The chapters will be pulled together in a single document, and then comes the hard part, turning it into an integrated, holistic book. There will be an editorial board, and presumably people to help with things like web pages, turning the manuscript into an actual ebook, and blogs and that kind of thing. So where we're going from with this, I don't know, but at least that ball is in play. And if you have any questions or thoughts, please let me know, or the board members. Thank you. Hyperloop safety study. So my name's Ian Sutton. My interest in Hyperloop is personal, or started as being personal. I live in a small town in the middle of Virginia, on the main line from Florida to the northeast. The first track was laid down in 1834, well before the Civil War. They're now talking about adding another track, and there's total turmoil in our community. It would destroy our town. And one of the initiatives I took on was, can we do a technological end run around this whole mess? Because all the issues we keep hearing about that we're running out of real estate is real. I mean, I see it every day. And so I started to look at Hyperloop. I'm also a chemical engineer. I've worked in many industries, and I've done risk management, safety management for probably 20 years. And yes, Hyperloop is a different technology from other industries, but when I started to look at it, I thought, you know, this looks familiar. I'm seeing a lot I recognize. I've written a paper on this. You can see the address there. It's at my website. The paper's already badly out of date, and I suppose I need to do a second revision, but you can download it if you want. How does this thing work? Which one do I press to make it go forward? I think this. Oh, I just do that.
Maybe you just need to use the arrow.
I just do the key. As an engineer, when I look at a new project or a new technology, I have two very simple questions. Will it work, and is it safe? There are, of course, other questions, like, is it profitable? What are the environmental impacts? What's the public relations impact? But I personally tend to focus on those two questions. In fact, the second one, is it safe? If the answer is no, you don't do the project, or else you figure out how to make it work and how to make it safe. Here's a summary of what my thoughts are at this stage. Whatever the industry you're in, bad events can happen, and I'll go through a few of them in a few minutes. The presentation we had yesterday about the Japanese railroad system was extremely impressive. They have such an extraordinary safety record. And obviously the goal with Hyperloop would be to match that, but it won't happen by itself. My argument is that safety is fundamentally a management issue, it's not a technical issue. Consequently, we can take management lessons from other industries and apply them with some degree of success. I'm suggesting that we prepare a generic safety study, or my preferred phrase, safety case. A safety case being the case you make to demonstrate to all stakeholders, including yourself, that what you're doing is safe. I think it's important for someone to take the initiative. Now's the time. It may already be getting too late to do this. I'm further suggesting that we work within a non-profit structure, and I'll give you 3 examples later of how we did this and how it worked. It was very successful. And learn from other industries. One thing that's come up in the last couple of days is this whole issue of freight and passenger. The top picture is taken from the balcony of our house. I'll sit there quite a long time reading books and writing books. The freight train's going by all the time. 2 miles long, 2 stacks high, of 53-foot high cube containers. And my initial vision of Hyperloop was that these huge ships would check into Jacksonville, Florida, or Norfolk, Virginia, and start unloading the containers. One. Every 30 seconds, these containers whizzing down the line. And I am a little concerned about the emphasis on passenger. A lot of the safety issues go away if you're talking about freight. The old motto, if a man's not there, he can't be killed, right? So what if you have an earthquake? So what? Well, you have to get a new container. Right? So I'm very interested in the idea of freight because, as we've heard already, passenger rail is almost always subsidized. Freight isn't. Freight makes money. And if we can persuade the freight companies to get an interest in this, suddenly I think the financial spigots may open. I write a safety moment every week, and I publish it on my website. This is one of the early ones. I've seen it throughout my career, but we're different, you know. Every industry has this attitude that they're different and they're special, and of course they're true. Every industry has things that's special. But they also have much in common, because safety is mostly to do with management systems rather than technology. If we can figure out. 3 examples. The first is nuclear power. Late 1960s, the nuclear power industry is getting started. A nuclear power plant is actually fairly simple, but they have one overriding huge concern. That's a release of radioactive materials. So what they did in about 1969, I think, they started to write a generic safety study for this growing industry. It was a safety study for a generic nuclear power plant. It wasn't any particular site. It was done by a non-profit. It was headed by academics. And out of this came the development of what we now call probabilistic risk analysis. And we use that now all the time. I use it all the time. It transferred to other industries. Was it successful? Yes and no. 8 years later, we had the 3 Mile Island fiasco in Pennsylvania, which was bad and could have been a whole lot worse. Why? Because they missed what we now call human factors. The next industry is chemicals. Now, the chemical industry, unlike Hyperloop, is very old, 150 years old. But in 1984, they had an accident which was so bad that basically the industry started again on safety. The accident was Bhopal in central India. There was a release of metal isocyanate, and depending who you believe, between 3,000 and 20,000 people died. It was the worst industrial accident in the history of the human race. And after this, the chemical industry said, something must be done. The second thing they said, and it was very clever, we're going to beat the regulators to it. So what they did, they took some experts from various chemical companies and working within a structure of a non-profit organization, developed what we now call process safety management. The elements of process safety management are really fairly simple. It's about management. It's risk-based, it's performance-based, it's non-prescriptive. The chemical industry has hundreds with thousands of technologies. You can't possibly write rules to cover them all. So what they said is, you figure out how to be safe, and the only measure of success is success. It's performance-based. And it's non-prescriptive. The regulation, when it did finally come out, was very slim. There wasn't much to it, which is good. It fit the needs of industry. It helped with production, productivity, and profits. The third, the way you organize process safety management, different companies, different facilities, different regulators, different industry organizations have different means, but they're all basically like this. These are dialects of a language. These are the elements of a management system. And that's how you manage safety on any industrial facility. Obviously, we don't have time to go through them, but that's what they are. Final example is offshore oil and gas. 30 years ago this month was the Piper Alpha disaster. Oil and gas, also like chemicals offshore, is not a new industry. The first large offshore platforms that were out of sight of land in the Gulf of Mexico were in the 1930s. But then we had Piper Alpha, a huge platform in the North Sea, blew up, caught fire and sank. taking with it, you can see British newspapers are not very circumspect. It says 167 dead. It's not true, it's 168. One man died later in the hospital of his injuries. Once more, we have this non-profit concept. The incident investigation followed this was remarkably well done, extremely detailed, very thorough, still quoted. And it was headed by a Scottish High Court judge called Lord Cullen. So that's our non-profit organization. And he said to the offshore industry, you need to do safety cases. And they did, and we have, and they work. The concept is, again, the non-prescriptive performance-based. The concept's widely used in military, aviation, and railroading. It's just the case you make before the accident to demonstrate that you're operating safely. A safety case or safety study, there's a series of them, obviously. Obviously, Hyperloop's at the first stage, right? Concept and technology evaluation. Obviously, big questions like, are we going to haul freight, need to be sorted out now, right? It's no use waiting until we get to detailed design. Because obviously, a lot of the very fundamental safety issues are going to depend on questions like that. The questions we've talked about with seismic. Maybe the safety case will say we're not going to build a Hyperloop in a seismically active area. I don't know. These questions need to be sorted out now. It's already getting very late. Later on, of course, we get to detailed design operations, even decommissioning. Decommissioning is a very big one offshore. So many platforms are being taken out of service in both the Gulf of Mexico and the North Sea. This is my poster yesterday. Regardless of the industry, you have those management elements I talked about, and this is how you do risk analysis. It's it's simple to say, it's hard to do. Identify the hazards, evaluate the consequences of those hazards, estimate the frequency, not the probability, but the frequency, estimate the overall risk, determine if the risk is acceptable, which takes us to the vexed topic of acceptable risk and what that means. If the risk is not acceptable, round we go again. And certainly I've been doing this for 25 years. It's sort of second nature. Conclusions. I don't know. I think I'm well within my time schedule. Bad events can happen in any industry. We don't want them to happen. We don't take them for granted. We're not being fatalistic. But I think from what I've heard, the reason the Japanese have been so successful is incredible attention to detail, meticulous, is hard work. Safety is fundamentally a management issue, and we can learn from other industries. And I think it's important to do so. I'm suggesting that we prepare a generic safety study or safety case, analogous to what the nuclear power industry did. That safety case should be developed within the framework of a non-profit. It seems to add I don't know why it works, but it does work. I think it adds an element of independence and integrity to the whole subject. I think we should consider both freight and passenger, because if you start talking about freight, you're talking about money, real money. And above all, take the initiative. Now's the time to act. Okay, thank you very much.
Curious about your take on another example of a failure analysis, and that's the Space Shuttle Challenger explosion in the aftermath, which I don't think was conducted under the auspices of a nonprofit.
That's correct, yeah.
But certainly an academic, at least sort of an academic person was very much involved in
what happened.
The story out. So could you talk about your take on that?
I don't claim to know anything special about the Challenger. I mean, I've read about it. I used to live in Houston, so it's sort of very central. But I think NASA probably has an element of almost independence by itself. It's not a profit-making institution. So the report it writes probably has a degree of integrity. Does that sound right? Rather.
Well, I guess I'm wondering whether you consider it a success case in terms of the way the response was or not. If you know.
I'd rather dodge the question. I really don't know.
I've seen some at one point, my understanding was NASA was trying to achieve certain failure rates, probability of failure. So they went through and they said each element has to have these probabilities of failure. And here's the combined of the entire system. And then after the disaster, they looked at it, and it was something fairly simple. And people said, why didn't you just fix the stupid part? And NASA pretty much at that point just abandoned that entire approach that they had and just said, we need to go through every part of the system, and if there's any question about it, we need to fix it. And they said, if we fix everything, that's the best way.
Another example of probabilistic risk analysis was the Japanese nuclear authorities said the chance of a fatality at the nuclear power plant is 1 in a million years. A few years later, Fukushima Daiichi happened.
Yes.
Right?
Exactly.
These analyses can be very optimistic.
And they can allow you to
I'm sorry, there's a gentleman at the back.
Yeah, I was just going to follow up on the nuclear industry. I'm curious if you really believe that it's a success, given the incidents that did occur in various places, and
All right.
also the fact that that industry as a whole is more or less collapsing for many factors. But I would argue that some of the regulatory environment around the nuclear industry, at least in the U.S., is part of the reason.
Yes, it's too burdensome. It's too again, nuclear is different because the worst case is really bad. It's really bad, right? I mean, if a chemical plant blows up, well, it's bad, but it's was it? I'm going back to that report, what's called Watch 1400. Was it a success? I think it was a success, but they missed human factors. The human factors thing was that one of the factors at 3 Mile Island was fixation. If you're in trouble with a nuclear reactor, you must keep the water levels high. Right? They had one instrument telling them the water level was too high, so they worked to lower the level. In fact, the instrument was lying. And they had other instruments who were telling the truth, but they fixated on the wrong instrument. So that was another problem with that report. The other issue that the nuclear industry just burdened with regulations, the chemical industry avoided that by making it prescriptive and non-prescriptive. It means, by the way, you can't be in compliance with the law. The only way to be in compliance in a risk-based system is never to have an accident. And no one can ever say that. So you can never actually be in compliance. Does that make sense? I'm sorry.
I picked up on some subtle hints that a nonprofit structure is the way to drive safety for an industry. We happen to be at a nonprofit for the Hyperloop industry. So what's the latest? Like, is it initial conversations about potentially working on safety as a nonprofit here, or are we already progressed a good bit? What's the latest?
I don't know. I have no knowledge. I don't know.
Was that a hint?
No.
Nonprofit?
Sorry.
How do you find the right balance between being able to do innovations and still keeping the system safe as possible?
Yeah, I'm sorry. So the question is about innovation and safety. I don't see there's a balance. I mean, innovations have to be checked for safety. I don't see why not.
Well, usually if you make something safe, or maybe it's you have to put in a lot of money, effort, and experiments to be able to
Right.
prove it's safe.
And I think Hyperloop will have to do that. This stuff isn't cheap. A safety case is not cheap. I'm sorry. Oh, well, you call it. You decide.
Let's go for one more question, and then we'll continue the discussion offline over coffee. Anu or Paul, who is going to ask the question?
Well, I think I want to just, you made the point repeatedly that safety is a management issue, which is what you have on the last slide too. But I think in the case of Japanese, I mean, a lot of, and also it was pointed out yesterday, that in the planning process, before you roll it out,
Right.
technology plays a fundamental role.
Absolutely.
And, having tight, My perfect example is this space competition that happened over the weekend, where safety wasn't, well, it was the overarching concern, but in the end, people that developed those pods, they only realized things go wrong when
Right.
they did go wrong. So the question is, how much planning do you do ahead of time before you actually implement the technology? So management is when after the thing is.
I would say that management is also in design. It's called safety in design. I've written a lot about it. That even at this stage with Hyperloop, it's a management issue, right? I mean, it's not managing detailed operations, but it's what level of risk do we accept? Welcome to that discussion, right? Am I making sense? It's still management.
It's expensive. I'm saying it's cheap, not expensive. Because if you don't do the right
Yeah,
thing,
okay.
it varies.
But it's expensive up front.
Put a little bit of money.
Yes.
Then it's cheap.
Yeah.